This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. On underground drainage work, the most expensive moment to discover a small coordination mistake is after soil or concrete has hidden it. I use one simple field rule: do not cover the work until the fall, the access, and the protection have been checked. The pipe needs continuous gravity fall. The system needs access for future service. Any concrete penetration needs physical protection. If one of those three is missed, the problem usually returns as a failed inspection, excavation, demolition, or a drainage defect. The central idea is that a gravity drainage line is not just pipe placed in a trench. Its performance depends on the relationship between elevation, direction, access, and the work that will later conceal it. A general building contractor does not take over plumbing design or drainage fixture unit sizing. I stay on the supervision side of the line. I coordinate the approved layout, verify visible field conditions, keep the work safe, and stop concealment when a required condition is missing. The first distinction is the boundary between the building drain and the building sewer. These names sound interchangeable, but the California Plumbing Code gives them different locations. The building drain is the lowest piping of the drainage system that receives discharge inside the building and carries it outward. It extends to 2 feet outside the building wall. At that point, the name changes. The building sewer begins at the end of the building drain and continues to the public sewer or to a private sewage disposal system. I put the two definitions side by side because the 2-foot boundary is the cleanest way to remember them. Inside and through the wall, continuing to 2 feet outside, think building drain. From that point toward the disposal connection, think building sewer. That distinction matters during coordination because the underbuilding work and the exterior sewer route can involve different excavation, access, inspection, and public connection conditions. I do not assume that calling everything the sewer is harmless. Precise language helps the plumbing contractor, concrete contractor, earthwork crew, inspector, and general contractor talk about the same section of pipe. A practical field check is simple. Find the outside face of the building wall. Measure the 2-foot transition point. Confirm that the plans, pipe route, cleanout location, and inspection sequence all agree with that boundary. I am not redesigning the system. I am making sure the installed work matches the approved work before it disappears. The normal minimum slope for horizontal drainage piping is a uniform 1/4 inch per foot, which is a 2% grade toward the point of disposal. The word uniform matters as much as the number. A pipe can start high and end low and still contain a flat spot, or a low section between those points. Overall fall does not excuse a local loss of grade. The practical effect is straightforward. Gravity carries water and waste through the line. When a section becomes too flat, flow slows and solids can settle. That is why I check the bedding and the full run, not only the elevation at each end. The approved fall needs to continue through the trench without a belly, hump, or unsupported section that changes after backfill. For a quick field calculation, a 40-foot run at 1/4 inch per foot needs 10 inches of total fall. That calculation does not design the drainage system. It gives the general contractor a coordination check against the approved elevations. The plumbing professional remains responsible for the system layout and sizing. There is a limited exception. Where the standard slope is impractical, piping from 4 inches through 6 inches may be installed at not less than 1/8 inch per foot, which is a 1% grade, but only with approval from the authority having jurisdiction. A crew cannot choose the flatter slope because the trench is inconvenient. An owner cannot authorize it. A general contractor cannot trade slope for schedule. The pipe size must qualify, the condition must justify the exception, and approval must come first. A 3-inch line does not fit that stated exception. That is an easy coordination trap because 1/8 inch per foot can sound like an acceptable alternate slope. It is not a general alternate. I remember it this way. 1/4 inch per foot is the baseline. 1/8 inch per foot is the approved larger pipe exception. The reference table groups the slope and cleanout numbers that are easiest to mix up. I still teach them by function. Slope moves the discharge. Cleanouts preserve service access. Clearance makes that access usable. A cleanout is not useful merely because it exists on a drawing. It has to be in the required location, remain accessible after finishes and landscaping, and have enough clear space for service equipment. At the transition between the building drain and the building sewer, the cleanout can be located inside near the connection or outside at the lower end of the building drain and extended to finish grade. The important supervision point is that the final condition must remain accessible. A cleanout buried under concrete, hidden behind fixed equipment, or covered by finished landscaping does not provide practical access. On a straight building sewer run, cleanouts are installed at intervals not exceeding 100 feet. Direction changes create a separate trigger. An additional cleanout is required when the aggregate horizontal change in direction exceeds 135 degrees. Aggregate means I add the turns together. Suppose a route uses a 45-degree turn, then a 90-degree turn, then another 45-degree turn to move around an obstruction. The total change is 180 degrees. That exceeds 135 degrees, so I coordinate an additional accessible cleanout before backfill. I do not look at each fitting in isolation and say that none of them individually exceeds the limit. The code also recognizes a narrow short-run condition. A building sewer or branch that is 10 feet or less runs as a direct straight-line projection from a building drain and is already served by an accessible cleanout does not need another cleanout merely at that connection. I treat every part of that condition as necessary. Short by itself is not enough. Straight by itself is not enough. The existing cleanout must actually serve the run and remain accessible. Access clearance depends on pipe size. A cleanout serving piping 2 inches or less needs at least 18 inches of clearance in front. A cleanout serving piping larger than 2 inches needs at least 24 inches. The difference is only 6 inches, but it can decide whether a drain machine or service cable can be positioned and fed into the line. This is one of those details that is easiest to protect early and hardest to repair late. Before walls, cabinets, mechanical equipment, paving, or landscaping lock the space down, I look from the cleanout outward and ask whether a plumber can actually work in front of it. I do not count open space that is shown on a plan, but will be occupied in the finished building. Concrete creates another concealment point. Piping that passes through concrete or masonry walls and through concrete floors needs a protective sleeve unless the opening is drilled or bored. Plumbing piping also should not be left in direct contact with concrete or masonry as though the pipe and the structure were one piece. The practical effect of the sleeve is separation. Concrete and piping can move differently as the building settles, temperatures change, and loads act on the structure. A sleeve or approved protective method prevents the penetration from being locked directly into the concrete. I do not need to invent a statewide sleeve thickness or a local material rule. The statewide coordination point is protection and separation in an approved manner. Imagine a pre-pour walk where a drain line crosses a formed grade beam. The pipe is positioned correctly, but it touches the form and reinforcing area with no sleeve around the penetration. The schedule pressure says to pour and fix the detail later. I stop the concealment instead. After the concrete hardens, access becomes demolition. Before the pour, the correction is coordination. I also distinguish a formed penetration from an opening drilled or bored through cured material, because the code language recognizes that exception. The field condition has to match the approved method. A rough opening left around a pipe is not automatically the same thing as a clean drilled or bored penetration. The pre-pour check is therefore direct. I confirm the pipe route, the approved elevation, the sleeve or approved protection, the separation from concrete, and the inspection status before authorizing placement. The concrete truck should not become the deadline that overrides the plumbing inspection. The trench can be ready for pipe and still be unsafe for a worker. At a depth of 4 feet or more, a trench excavation needs a safe means of egress, such as a stairway, ladder, or ramp. That egress has to be positioned so an employee does not travel more than 25 feet laterally to reach it. The two numbers work together. The 4-foot measurement tells me when the egress rule is triggered. The 25-foot measurement tells me how close the exit must be. A ladder at one far end of a long trench does not satisfy the rule for a worker who is farther than the permitted travel distance. Consider a hypothetical 60-foot trench that reaches 4.5 feet in depth along the active work area. One ladder sits at the street end. A worker near the middle could be about 30 feet from that ladder. I do not send the worker in and promise that another ladder is coming. I reposition or add egress first, so every employee in the qualifying portion of the trench stays within 25 feet of an exit. Egress is a separate safety decision from the protective system required for cave-in hazards. I do not wait for another trench threshold before providing the ladder, stairway, or ramp required at 4 feet. I also do not treat a ladder as proof that the excavation itself is safe. A competent person is capable of identifying existing and predictable hazards and has the employer's authority to take prompt corrective measures. That person inspects the excavation before work begins and as conditions change. Conditions can change during the work, so the inspection responsibility does not end after the first look. The title matters less than the actual knowledge and authority to stop the work and correct the condition. The checklist puts the hold points in construction order. Before entry, verify the trench. Before cover, verify slope and cleanouts. Before concrete, verify the protected penetration. Each check happens while correction is still practical. I want to walk through the full coordination sequence as a general building contractor would encounter it. Before anyone enters the excavation, I make sure the competent person has evaluated the trench and that required egress is in place. If the trench is 4 feet or deeper, I verify that a worker never has to travel more than 25 feet laterally to a stairway, ladder, or ramp. Before the pipe is covered, I identify the building drain and building sewer boundary at 2 feet outside the wall. I compare the installed route and elevations with the approved plans. I verify a uniform 1/4 inch per foot baseline slope unless the larger pipe exception has been approved by the authority having jurisdiction. I then check the cleanouts. I confirm the transition access, the 100-foot maximum spacing on straight sewer runs, any additional cleanout required when aggregate horizontal turns exceed 135 degrees, and the front clearance. That means 18 inches for piping 2 inches or less and 24 inches for piping larger than 2 inches. Before concrete, I verify that penetrations through concrete or masonry are sleeved or otherwise protected as required, unless the opening qualifies as drilled or bored. I do not let the pipe become directly embedded and then call the detail complete because the location looks right. Finally, I confirm the required inspection and authorization before backfill or concrete placement. The general building skill here is not hidden design mathematics. It is recognizing visible requirements, coordinating the trades, holding the sequence, and refusing to bury a known conflict. The memory numbers from the report are 2, 4, 25, and 100. The building drain reaches 2 feet outside the wall. Trench egress begins at 4 feet of depth. Maximum lateral travel to that egress is 25 feet. Straight run building sewer cleanouts are spaced no more than 100 feet apart. I keep the remaining pairs separate. The normal slope is 1/4 inch per foot. The 1/8 inch per foot slope is an approved exception for qualifying larger pipe. Cleanout clearance is 18 inches for piping 2 inches or less and 24 inches for larger piping. Direction changes trigger another cleanout when the aggregate exceeds 135 degrees. The final field question is not whether the underground work looks close enough. It is whether the visible installation preserves gravity flow, future access, physical protection, and safe entry before the work is concealed. That is a testable coordination concept based on the published CSLB study outline, and it stays squarely within the general building supervision role. Before I let you go, I made an audio practice quiz for this specific episode's material. The questions are read aloud and you answer by tapping, because I know a lot of your studying happens while you're driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about drain slope, building sewers, cleanouts, sleeves, or trench egress. Subscribe so I can help you stay on track through every episode until you get your license. I am building this one lesson at a time for people who are doing the work and still making time to study, and I want to see you finish what you started.